Question 6. An electric heater uses a resistance wire of resistance 26 ohm. The power dissipated in the resistance wire is 2500 watts. Question A. Calculate the current in the resistance wire. To get started on a calculate question, list all the known quantities given to you. From here onwards, we need to apply a formula to calculate the value of current. But if you don't know what formula to apply, list down all the formula you know related to power. So let's compare the information given with the formulas that we have. We have resistance and power, and we need to find current. So the formula that we should apply would be power equals to current square multiplied by resistance. Since we're looking for current, we can rearrange the formula like this. After substituting the values and calculating them, you will get a current of 9.8 amperes. Don't forget your units, and you can leave your answers in two significant figures. Question B. The resistance wire of the heater has a length of 1.2 meters and a cross-sectional area of 7.9 times 10 to the power of negative 7 meters square. A new heater is designed using wire of the same material with length 1.8 meters and cross-sectional area of 5.8 times 10 to the power of negative 7 meters square. Calculate the resistance of this wire. Okay, we are going to follow the same method for this question by listing down all the known quantities given first. The relationship between resistance, length, and area given the same material can be expressed like this. From here onwards, to find the resistance of the new heater, we can just use the ratio method to directly compare resistance 1 and resistance 2. So let's simplify this equation and substitute all the known values. From here, you will get the value of resistance 2, which is 53.12 ohms, and you can just write your final answer as two significant figures. Again, do not forget your units. Question C. The 2500 watts heater is used in a country where electricity costs $0.3 per kilowatt hour. Calculate the cost of using the heater continuously for 2 days. Again, it's a question about calculate, so list down all the quantities that you know. Since we are looking for cost, it has already been mentioned here that it should be per kilowatt and per hour. So your step 1 should be to convert the power in watts into kilowatts. The next step is to find out how many hours is equivalent to 2 days. Okay, now that we have our kilowatts and hours, let's find out how many kilowatt hour do we have. Okay, so now we know that the power consumption continuously for 2 days is 120 kilowatts hour. Okay, so now you can calculate the cost. So you have $0.3 per kilowatt hour. And we know that the power consumption for 2 days is 120 kilowatts hour. So your cost is $36. Question 7. The voltage across the primary coil of a 100% efficient transformer is 220 voltage and the voltage across the secondary coil is 12 voltage. Question A. The current in the secondary coil is 2.5 amperes. Calculate the current in the primary coil. If a transformer is 100% efficient, the input power is equal to the output power. The equation to calculate power is voltage multiplied by current. So let's apply this here. So just rearrange your formula and you will get the current in the primary coil, which is 0.136 ampere. Simplify your answer to two significant figure would be 0.14 unit ampere. Question B. Calculate the ratio of the number of turns on the primary coil to the number of turns on the secondary coil. Okay, this is a very simple question and you should know how to calculate ratio when it comes to transformer. The formula is the number of turns in primary coil over the number of turns in secondary coil is equals to the primary voltage over the secondary voltage. Okay, so the voltage of the primary coil is already given in the first part of the question, which is 220 voltage, and for secondary coil it is 12 voltage. So the number of turns of primary coil to secondary coil can be simplified as 18 to 1. Question 8. A. During beta decay, one of the neutrons in the nucleus changes. Part 1. State what happens to this neutron. Beta particles are fast-moving electrons. They are produced in nuclei when a neutron changes into a proton and an electron. So for 1 mark, you can say that during beta decay, a neutron changes into a proton and an electron. Part 2. Explain how charge is conserved during this change. Okay, let's look at a sample decay equation to answer this question. As you can see here, the proton number of this helium atom has become 2, meaning that it has gained 1 proton. And since it releases beta, it has gained 1 electron. So we have got positive 1 and negative 1, giving us a total net charge of 0. So when you get a total charge of 0, your charge is conserved. Question B. Complete the nuclide equation for the alpha decay of radon-212 to form an isotope of polonium, symbol PO. Note that this is an alpha decay. The first step is to recall alpha particles' mass and atomic number. These are 4 and 2. Next, we can write the information we already have into the decay equation. Remember, mass number is conserved, so radon's mass number is the sum of polonium with alpha particle. So a quick rearranging shows us that polonium has a mass number of 208. Repeat the same step to find the proton number of polonium. And it is 84 here. Question 9. Figure 9.1 shows the Sun as the central dot and the planets Saturn, Jupiter, and Earth labeled S0, J0, and E0. The planets orbit the Sun anticlockwise. From the Earth's orbit, the planets appear aligned. Assume that Saturn takes 30 years to orbit the Sun and Jupiter takes 12 years to orbit the Sun. Question A. On figure 9.1, mark the positions of Saturn and Jupiter 5 years after the original position shown. Label these positions S1 and J1. Show your working. Alright, to show your working for this question, it has nothing to do with your physics knowledge but more to your mathematical skill. For Saturn to orbit around the Sun and return to its original position, this means that it took a complete circle of 360 degrees, which is equivalent to 30 years. If we want to find the position of Saturn after 5 years, we need to find at which angle the position of Saturn would be. Using the ratio method, we can find out that after 5 years, Saturn would be at a 60-degree angle. So now let's go back to this diagram. So using your protractor, find 60-degree angle starting from S0. And let's mark this position as X. So this angle is 60 degree and they want you to label the position of Saturn after 5 years as S1. Okay, done. Next, we're going to repeat the same thing for Jupiter. If Jupiter takes 12 years to complete a full circle of 360 degrees, at what angle would Jupiter be after 5 years? And you will get an angle of 150 degrees after 5 years. Okay, let's repeat the same steps. Since the planets are traveling anti-clockwise, the direction of your angle should be in this direction. So 150 degrees from this point will end here, like this. This is 150 degrees. Let's mark this position as X. And the question wants you to label the position of Jupiter after 5 years as J1. Okay, you have labeled your positions and shown your working. You should be able to get a complete 3 marks. Question B. Part 1. On figure 9.1, mark the positions of Saturn and Jupiter 20 years after the original position shown in figure 9.1. Label these positions as S2 and J2. Okay, we'll repeat using the same method. After 20 years, the position of Saturn would be in an angle of anti-clockwise from where it started. And for Jupiter, it would be at an angle of 600 degree. So 600 degree mean that it has completed one full circle of 360 degree plus another 240 degree angle anti-clockwise. So let's use our protractor and find the positions of S2 and J2 on the diagram given here. Okay, so now we are looking to find 240 degree angle from the original position, which is here. So half a circle meaning that it has already traveled 180 degree, and we need to find another 60 degree from here, which would be at this angle. So Jupiter will be positioned here, and we will label it as J1, and Saturn will be positioned here, we will label it as S1. Okay, now this is done. Going back to our question. Part 2. State what is observed from Earth's orbit after 20 years. So after 20 years from the Earth's orbit, we can see that Jupiter and Saturn are aligned after one another. Question C, Part 1. Choose 2 words from the list to describe each planet. Jupiter is known to be very large and gaseous compared to the size of Earth, which is small and rocky. Part 2. The average density of Jupiter is much less than of the Earth. The gravitational field strength at the surface of Jupiter is greater than at the surface of the Earth. Okay, explain how these differences in density and in gravitational field strength are consistent with your answers to C Part 1. To get you started on an explain question, use the words from the question to begin your answer. When you are explaining something, you need to say why it happens. So make sure you include the word because or something similar to ensure that you are fully answering the question. So, the density of Jupiter is much less than of Earth because it is composed of gas and the Earth is solid. Next, for the gravitational field strength, Jupiter has a large gravitational field strength because it has a large mass. Question D. The average density of Jupiter is 1,300 kilograms per meter cube and the volume is 1.4 times 10 to the power of 15 kilometers cube. Calculate the mass of Jupiter. The formula to calculate density is the unit of density of Jupiter is in kilogram per meter cube. This means that your mass has to be in kilogram and your volume has to be in meter cubes. The question has given its volume in kilometer cubes. That means your first step should be to convert kilometers cube to meters cube. Now let's substitute all the values that you have into the formula of density. Since you're looking for mass, just rearrange your formula and you will get the mass of Jupiter, which is 1.82 times 10 to the power of 27 units kilogram. Simplify this to 2 significant figures and you would get 1.8 times 10 to the power of 27 kilograms. Question 10a. Show that 1 light year is equals to 9.5 times 10 to the power of 15 meters. We can show this using a simple calculation. We know that the speed of light in a vacuum is approximately 3 times 10 to the power of 8 meters per second. This means that light travels a distance of 3 times 10 to the power of 8 meters in 1 second. To find out how far light travels in 1 year, we need to multiply the speed of light by the number of seconds in 1 year. Now let's do the calculation, and the number of seconds in 1 year is 31,536,000 seconds. Okay, so distance equals to the speed of light multiplied by the number of seconds in 1 year. You would get a distance of 9.46 times 10 to the power of 15 meters, which is approximately 9.5 times 10 to the power of 15 meters. So you have shown that it is equals to 1 light year. Question B, Part 1. State one measurement that is taken when determining the speed v at which a galaxy is moving away from the Earth. When a galaxy is moving away from the Earth, the light emitted from distant galaxies appears redshifted. And redshift is an increase in the observed wavelength of electromagnetic radiation emitted from receding stars and galaxies. So the measurement that is taken would be your change of wavelength. Part 2. Write down an equation relating v and the distance d of a faraway galaxy. The equation relating v and distance is your Hubble constant. Part 3. State how the distance of a far galaxy can be determined other than by using the equation in Part 2. Okay, this is a theory question. To calculate the speed, we can either find the change of wavelength or we can determine it by using the brightness of a supernova in that galaxy. Okay, that is all for this paper. Thank you for watching the video until the end. I hope it was worth your time. And if you have any questions, please ask me in the comment sections below.